presenting it to the public. They think this is for everyone. Like, there's a lot of people who need this information. There's these universities that have a lot of people, massage therapists, osteopaths, chiropractors, and in America, it's like the only people who get exposed to the highest level stuff are literally the people who are discovering it, and not the doctors. No, doctors do not get very high level stuff because they're always worried about more learning diagnostic protocols, specifications for practice. By the time they're done with all of their residency, they've forgotten the middle level of anatomy and stuff that they were taught in medical school. But it's okay because they're going to practice in this scope. You see what I'm saying? Yoga practices in a universal scope. So there is nothing that it's not touching on. So understanding the complexity of anatomy is much more important as a yoga practitioner even than it is as an orthopedic surgeon who works only on knee replacements. Sure, you need to know the knee very well, but to me it doesn't even make sense to not know everything else, because as we showed before, the knee is the pelvis is the lumbar spine is the diaphragm is the rib cage is the cervical, Next thing you know, there's not a part of your eye could be turned up because something's wrong with your knee. Like your right eye could literally have a hard time looking down. That's possible. So one thing that's important, and I think what we'll do after the video is talk a little bit more about the muscles and bones and posture and the diaphragms and how they're related specific to yoga before going through some more of this stuff. I really do want everybody to understand the fascia that we've already covered. We've covered all the fascia that's important. Understanding the diaphragm being the separation of the two spaces, that it is attached to the pleura, it's attached to the pericardium, that it creates a fluctuation in pressure and tension that nourishes and allows for the appropriate function of these very important organs is really key, because a healthy diaphragm is a healthy lungs, a healthy heart. Or a better way of saying it is, if the diaphragm is compromised, it is an obligation that the heart, lungs, liver, intestines will be compromised. It's much easier to work with the diaphragm than to work with these other organs. So a really good way to maintain or prevent bad health is to make sure your diaphragm's healthy, and yoga is a very good way to make sure that your diaphragm's healthy. But like we're about to see, it's important to think of it in context. With respect to the three diaphragms, will you say the bandha names again?
Yeah, and then I've got a question.
Okay.
So Mula Bandha is the pelvic floor diaphragm. Uddiyana Bandha is this diaphragm. We call it, we've sort of dumbed it down, if you will, a little bit and talked about the contraction of the upper fibers of the transverse abdominals, this Uddiyana Bandha. It's translated directly as the upward flying walk because there's photos of and practices where you literally suck the diaphragm up.
Mm-hmm.
And that's next to those photos it will say Uddiyana Bandha. And then Jalandhar Bandha is the throat lock bandha.
Okay.
So it's Mula.
And those are all three going to be in this video, but also it's important to understand, and you'll kind of see that, well, I'll talk about that after the video. Because what you're saying about the bandha being the diaphragm and the transverse abdominis and the upper fibers makes sense a lot, because you have to have a structure for the diaphragm to pull on. If I pull on this computer, I don't move towards the computer, it moves towards me. Something has to hold on to the computer very strongly in that direction in order for me to pull myself. So if I wanted to pull this closer to the computer, or if I wanted to pull this, if the computer was over here, and I wanted to pull this there by pulling on the computer, this would have to be very strong enough for me to pull my body this way. The diaphragm is pushing all of the organs, this thing, in that direction, past the computer, which is the ribs. So what is holding on to the rib to keep the diaphragm from just pulling the ribs up? That's the transverse abdominis. That's the internal obliques and stuff. But at the top, it is best if it's the transverse abdominis. It needs to be. Because the rectus abdominis, which also attaches to the very top, attaches above, and that's when you start to get compression in the xiphoid process. You can have a lot of problems if the rectus abdominis is trying to do it. It's way too big and strong a muscle, and it's not containing like the transverse abdominis, because the horizontal fibers, but the horizontal fibers, the transverse abdominis up here, are just across like that. Down here, it starts to be attached to the thoracico-lumbar fascia, but up here, it's like that. So it's a good way of locking the ribs in place so the diaphragm can pull itself down towards. Do you see what I'm saying? So they work in union. People think of them as opposing, but they are not opposing.
Yeah.
Just like the hamstrings aren't opposing forward bend. Like this, they're allowing forward bend.
Yeah.
The diaphragm isn't opposing breathing in, it's allowing it by fixing with enough pressure the ribs so that they don't just fly apart when the diaphragm tries to pull down.
Yeah, and that's a common misalignment or weakness is the shallow breath where you just see the chest moving and you don't see the expansion.
More of the scalenes pulling the ribs up, more of the intercostal muscles pulling the ribs up, trying to expand the lungs from the top because the diaphragm isn't moving down. And the diaphragm can pull the ribs up. We're about to see.
Can I ask you my other questions before I forget? So, two other things that I have in my brain from previous teachers. There's a practice, a pranayama practice called kumbhaka, which is breath retention. And it's said that holding yourself full of air allows for more time for gas exchange, that it would oxygenate the blood more if you hold your lungs full of air and then exhale. Is that true?
Yes, but it's way more complicated than only that, because some people would say that's bad, because if you don't allow the carbon dioxide to leave, you can begin to build up. Anyway, they're wrong. It's not the right way to think of it. But here's the most important thing, is that when you, for instance, slow your breath out more than your breath in, okay? You're allowing oxygen to come in as quickly as possible. You're giving it time to oxygenate. That's like holding your breath, breathing out slowly. You see what I'm saying? Mm-hmm. Is that something in yoga, breathing out faster, breathing out slower than you breathe in?
More slowly. There's all kinds of different pranayama practices, so that is one of them. But for asana, we usually use ujjayi breath, and we match the length of the inhale to the length of the exhale.
There's no problem with that. Actually, just breathing in and out slower will do a similar thing. It'll bring oxygen in less quickly, but it will still slow how fast the carbon dioxide leaves. As you slow how fast the carbon dioxide leaves, you increase the carbon dioxide gradient within the blood, and that increases the gradient of carbon dioxide to oxygen. And that's the most important chemical process. They call it the Bohr effect, where because there is more carbon dioxide near the cells, it's like a backup effect. It's like the more that's in the blood, the less leaves the space around the cell, because it's literally a diffusion gradient. The less carbon dioxide there is further down the line, the faster it leaves. You see what I'm saying? So if you back up the blood, because there's less carbon dioxide in the atmosphere, like 0.5%, the carbon dioxide leaves the blood very fast whenever we breathe out. Lots of carbon dioxide. If we keep more carbon dioxide in the blood, then when the oxygen attaches to the hemoglobin on the red blood cell and it travels down to the cell, eventually it gets to a carbon dioxide gradient that's so significant the oxygen begins to be pulled off of the hemoglobin and carbon dioxide replaces it. But it takes a lot of carbon dioxide in the environment for that effect to happen. Once the oxygen is freed from the hemoglobin, the iron molecule within the red blood cell, now it can travel into the cell and oxygenate the cell. So by slowing or holding your breath, you are able to increase the carbon dioxide gradient within the blood, and you increase oxygen delivery, not just because you give it more time, but because the chemical effect is more efficient. Does that make sense? Mm-hmm. So carbon dioxide I look at as the most important gas between oxygen and carbon dioxide. Carbon dioxide is more important. When you die of shock, it is because there's so little carbon dioxide in the extracellular space that the oxygen doesn't leave the blood cells. So the venous blood is red just like the arterial blood. So it comes into the lungs, leaves with oxygen, but in shock, when your cells are no longer producing carbon dioxide, the red blood cell gets down there, the oxygen doesn't leave, it goes right back in the vein, and it comes back to the lungs already red, and you're suffocating. Not because you can't get oxygen in, but because you don't have carbon dioxide. So you have to give carbon dioxide to somebody, like breathing in a paper bag, things like that. Does that make sense? Mm-hmm. So so the slower breathing is important because it increases the efficiency of the delivery from the red blood cell to the. Conversely, if you have more carbon dioxide in the blood, then oxygen is going to be more strongly attracted to the blood because it travels along a diffusion gradient. So the less oxygen and more carbon dioxide you have in the blood, the more oxygen delivers from the atmosphere into the blood. And that's, yeah. Does that answer the question?
Yeah. So if you were to give someone that was in shock oxygen,
You would kill them.
you'd kill them.
Yeah. They call it hyperventilation. And it happens all the time in hospitals. It's one of the leading causes of death in the hospital is hyperventilation.
Why did they do that in the hospital?
Because they're back in the 30s and 40s, they wouldn't. They understood every single fireman and every EMT had 5% carbon dioxide tanks so that they could increase carbon dioxide. There was this idea that carbon dioxide was a poison that needed to be released. I can't say it more intelligently than that because I don't think it's an intelligent concept, but it's very pervasive in medicine that you need to increase oxygen, increase oxygen, increase oxygen. It's not untrue that if you increase the oxygen gradient, you will override a poor carbon dioxide gradient initially, but you aren't going to be solving the actual problem, which is, so if we have, I forget, but it's not a very, I think it's like 13% oxygen and 0.5% carbon dioxide in the atmosphere. If you increase it to 90% oxygen, which is I think a lot of times the pure oxygen blends, it's 90% oxygen and 10% nitrogen or something like this, I think. Then what happens is you do deliver more oxygen to the blood, but what doesn't happen efficiently is increasing the carbon dioxide gradient. So you're not fixing the problem once the oxygen gets to the cell. Do you see what I'm saying? So sure, more's coming in through the lungs, but it's not necessarily the case that more is getting into the cell. And if it's gone too far down that path and the oxygen isn't delivering well, you will make it worse and poison the person with too much oxygen. And oxygen is very volatile. So you don't want oxygen. Once the oxygen's in there, you want it attached to the blood cell. Once it's off the blood cell, you want it going straight to the mitochondria. You don't want it doing anything else. There's not many, I can't think of one right off the bat. I don't think there are any other useful purposes for free oxygen in the system other than destroying proteins and creating all types of really bad stuff. So oxidized particles are a marker of aging and dishealth. And that is because free or ambient oxygen, they'll call it, is being allowed to interact with molecules in a way that is not useful in the system. Just like I call it the beaker effect. If you put things in a beaker, they'll do something. The biological system is always doing something on purpose. There's never a moment a molecule isn't being handed from one to another. Otherwise, I say it's not the biological system, it's just accidents or whatever you want to call it. You know, it's bad processes that have to be, then we have to heal. But so, by breathing in that way, carbon dioxide is very protective against that. Proteins will maintain their viability for a very long time, so that's why you can preserve things by putting carbon dioxide. If you have a bag and you put carbon dioxide in the bag and you seal it, and all the oxygen is gone, the food won't rot. Because the oxygen is what creates the rotting process. Basically, simply, it preserves the protein. And that's the same in the system. So people who drowned in very cold temperatures and the process is slow a lot and carbon dioxide is very, very high compared to oxygen, they can be revived like a long time later with no damage to their brain. because all the proteins were held in exactly the right orientation as before they died. And so when they're revived, it's like everything works. It's like what you would call suspended animation. And that happens. There's a woman who fell through a big like cave into like an icy cave somewhere hiking around, and I think like she was a cardiologist and her husband was, she was a neurologist and her husband. So no one else would have gotten the treatment. No one else, but they theorized this could preserve this person. Let's wake her back up. Everyone else, they would have said, don't wake him up. You don't want to see what happens. So they did, and she's fine. It's something you can, and I think she had an interview on NPR and stuff too. But they don't describe it the way I just described it with the carbon dioxide preserving and stuff. But they have suffocated mice, for instance, in carbon dioxide. Horrible thing to do. I know some of this, the experiments are awful, but the information's there. So anyway, I don't think they should have done it, but they did. And they would revive the mice hours later, and they would be just like they were before. Or frogs burying themselves in mud and not letting the carbon dioxide leave their skin, because that's a big way that they breathe, and then they can be buried underwater for 20 years, and then the water dries up and the frogs hop away. Or like once they buried them in a foundation of a big building in downtown New York, and when they broke the foundation after they removed the building, 50 years later, the frogs hop out of the cement. That's happened in real life. But it's because you don't die necessarily if all of the life is arranged appropriately. You know what I'm saying? The energetic coherence is still available as soon as the process is reinitiated. I'm sure that's the theory with freezing people, but I'm not going to risk it. I'll just let myself pass on.
Okay, I got one more question. So inversions in yoga, if you stay in them a long time and your diaphragm is, the other way against gravity, does that make your diaphragm stronger?
Yes, it's exactly what I was going to talk about later. Was if it's even the case if you're in child's pose. I'll just talk about it now because we just talked about it. But if you're in child's pose, right? For me, because I can do this, but I'm not. But you're going to be not allowing the expansion of the stomach. And so you're going to increase the expansion of the thoracolumbar fascia. Because this is so easy to expand, this will just not really expand. But now it's not easy to expand because you have gravity and your pressure. So you'll expand more here, you'll expand more in the ribs. But also, you'll expand more in the pelvic diaphragm. And for instance, if you were to breathe in that position and then contract the pelvic diaphragm, now you've got this space that's going to try and absorb that pressure that the pelvic diaphragm has placed, and you're going to strengthen the pelvic. The name of it?
Mula Bandha.
The Ula Bandha. Mula Bandha. So there's a lot of different ways you could breathe. Like Ujjayi breathing would really be a good way to strengthen the pelvic diaphragm, I think, in that position. But if you breathe too passively, you might stretch the pelvic diaphragm in that position. And your question exactly was
if you are
if you're laying on your back, you're going to strengthen
completely upside down, like say in a handstand or shoulder stand.
But even less than that, if you're on your back, you're going to increase the strength of a very specific part of the thoracic diaphragm. It's the part that is going to be resisting gravity the most. Now you'll strengthen all of it more, but if you're upside down, it's going to be the hardest you could possibly be. And in particular, it's going to be hard for the anterior dome on your stomach, the pillars of the diaphragm. So it's going to be for the posterior dome of the diaphragm. But anyhow, the importance is that even the different parts